Why electric vehicles are burning and exploding. All EV companies are recalling its electric two-wheelers. You must have seen a spate of reports over the last few weeks about electric scooters catching fire in India. The incidents are a worry, not just for India's fledgling vehicle industry, but for all folks who have made or are thinking of making the switch. Now, sales of electric scooters have more than doubled this year. Recently, there have been widespread incidents of electric two-wheelers catching fire in various parts of the country, forcing manufacturers to recall their vehicles. In April, Ola Electric had recalled 1,441 units of its electric two-wheelers. The company said its battery systems already comply with, and is tested for ISE 156, the latest proposed standard for India, in addition to being compliant with the European standard ECE 136. Boom Motors recalled its electric two-wheelers, sold under the Corbett Bikes brand, in the last week of April, after an explosion of one of its units in Andhra Pradesh, Vijayawada, reportedly led to the death of a 40-year-old man. Pure EV decided to recall around 2,000 of its scooters, after an 80-year-old man in Telangana, Nizamabad, died due to an alleged explosion of a battery of one of its scooters. The Indian government is revising automotive industry standards, A.K.S. 156, to align it with countries like Japan, Germany, and the US. Is there any solutions? A report by the Defense Research and Development Organization's DRDO, Center for Fire Explosive and Environment Safety, points it to the EV batteries. The issues highlighted includes poor quality cells, lack of fuse, issues with thermal management, and battery management system, BMS. The highlighted issues cause the batteries to experience thermal runaway problem, leading to the fires. This phenomenon occurs when an increase in temperature changes the conditions that causes increase in temperature, leads to explosion. The issue highlighted by the DRDO report are all potential causes of thermal runaway. Let's explain why. Local atmospheric temperature directly affects the operating temperature of battery. For efficient performance, battery's operating temperature should be 20 degrees to 35 degrees Celsius. To keep the battery at this temperature, EV need battery thermal management system. Now, with rising temperatures in our cities, the BTMS are being challenged, and possibly due to the poor thermal management system of EV batteries, thermal runaway is being caused. Another cause for the thermal runaway is possibly due to the rapid battery charging. With the evolution of battery technology, charging technology is also advancing. While the fast charging can greatly improve the convenience of EVs, it increases the risks related to batteries. Fast charging an EV can overheat the battery system, enough to melt the electrical wires and cause short circuits, leading to explosive consequences, as already seen by several charging-related incidents. The causes of thermal runaway highlighted above could be due to either inefficient design or not enough testing by EV manufacturers. But the manufacturers cannot spend more time on increased testing due to time-to-market constraints. What's the solution? Thermal runaway is a complex engineering problem, entailing all the types of simulations mentioned above. With the right simulation tools, simulations allow to mimic every possible physical condition, rising temperature, fast charging, or fuse placement, and find areas of problem. After identifying, it can also aid in testing different solutions and hence avoid thermal runaway altogether. To run a series of simulations, it can take months to obtain results with minimal flaws and defects. Manufacturers cannot afford this as it greatly hampers the time to market. Thus, companies opt for simulations that can provide solutions but with several minor flaws and defects to them, leading to large mishaps like EV explosions, system failures, and affecting human lives. So the real issue is the computing technology bottleneck. This is where the next generation computing technology of quantum computers can step in and revolutionize the industries like EV and battery design. The power quantum computers is showcased by its ability to perform the same simulations in much less time compared to classical supercomputers. Hence, this technology can significantly help EV manufacturers in their time to market. Good news is that companies are already developing and building quantum-powered simulation software, which can solve problems of thermal runaway and optimization of BTMS. Quantum computing is here and now. Now let's see how BMW electric vehicle is using quantum computer for battery management system.